Good day. Today we shall be talking about gravitation. We shall attempt to understand this most fundamental of forces which is all around us and trace in a way humanity's understanding of this force from the times of Aristotle through Galileo, Newton and finally culminating with Einstein's grand vision of space and time. Before going any further though, it is very clear that we all have a fundamental understanding, an intuitive grasp of what gravity is. From the time we were born to the time we took our first steps, we took a lot of effort to overcome Earth's gravitational force on us. Even when we walked as toddlers, we were afraid of succumbing to Earth's gravity and falling over again. We see gravity in other things in daily life as well. We see the raindrops coming down from rain clouds, right here. That's due to gravity. Fruits such as the apple, which probably fell on Sir Isaac Newton's head, that's due to gravity. To better understand another place where gravity plays an important role, we could consider the solar system. Agreed, this is not to scale, but if the orange ball represents the sun, the model of the globe represents the earth, and the little green ball represents the moon, it's gravity which makes the earth go around the sun, and in turn makes the moon go around the earth. So, mankind really did not need an introduction to what gravity is. Why things fall down seem to be quite intuitive. Aristotle, the great ancient Greek philosopher, reasoned that it is inherent in the nature of heavier bodies to fall. According to Aristotle then, a heavier object must fall faster than a lighter object. This view persisted for over 2000 years with little challenge till Galileo came along and decided to challenge this view. Let's see what he did. I take up these two balls, this one which used to stand in for the sun and the little one which was probably the moon. Clearly, the orange ball is bigger and heavier than the green ball. If I release them together, Aristotle would say that the orange ball should hit the ground first. Let's see what happens. You can see instantly that both balls hit the ground nearly together. Galileo was right. He said that all objects, whether heavy or light, will fall from a given height and hit the ground at the same time. He had turned the understanding of why objects fall on their head. Still, Galileo's other contribution, the telescope, would spur on another great astronomer, Tycho Brahe, to observe the orbits of various planets. Johannes Kepler would then collate this data and turn it into knowledge that planets revolve around the sun not in circular but in elliptical orbits. Allow me in a moment to show what I mean by this. Instead of having the sun here, which I showed in my figure, and having a planet like say the Earth go around it in a perfect circle, Kepler reasoned that the sun sits at the focus of an ellipse, one of the foci, and the orbit is really elliptical. So the green one is what really happens. This orbit is called an ellipse, and Kepler proved beyond a shadow of a doubt that planets go around the sun in ellipses. In England, a young scientist asked, what force is it that causes planets to go around the sun in elliptical orbits? He reasoned that the force is inversely proportional to the square of the distance separating the sun and the planet.